Protocol 23, we are introducing the hot archive bucket list, where we will actually store archived entries in a separate database. And what this allows us to do is to store all live Soroban state in memory, as well as store instantiated module caches in memory. And we can do this safely because the rent system is archival. So what we were talking about today is an update that we made since the last time we talked, particularly about the way that we calculate the what today is called the target bucket list size. And so in Protocol 22, whenever you pay rent or write an entry to the ledger, this fee is variable based on the current size of the bucket list, which is just the size of the network's database on disk. And essentially, we have a target size, and if this target size is exceeded, then the cost of writes and rent bumps increase very rapidly. And essentially, this allows us to have a soft cap on the current size of the bucket list or the network database from a fee perspective. So you can technically still write, but it'll just be very expensive to do so. So people will stop writing, and then eviction and archival will do a back pressure to over time reduce the size of the bucket list. Now the thing is, previous to Protocol 23, this was all measured in database size. Now there were two issues with this. The first one being that this is a Soroban-based fee, and most of the Soroban state, or most of the core database wasn't Soroban state. Classic state significantly dominated the size. And so we had this weird system where even though Soroban took up very little space in the bucket list, it was being charged fees whenever classic entries would make changes. So that's kind of issue number one, that you have classic influencing the cost of Soroban state. Now, the second issue is that with Protocol 23, we now have a bunch of storage, or all the Soroban state, that we actually store in memory instead of on disk. And so it would our kind of goal with this setting is to make sure that the protocol can cap the maximum amount of memory that validators have to use at any given time. And if we were to continue to use just the disk-based metric, this is no longer able to actually cap the amount of memory that you need to store now that we cache everything in memory. And so the update to CAP-0066 is that we change the bucket list target size bytes to Soroban live state target size bytes. And so what this means is that instead of using the entire size of the database to calculate rent fees and write fees, we only use the size of the live Soroban state that we actually have to store in memory. Now, there's a couple of details here. Particularly, I want to talk about contract code. And so when storing, so the plan is to store all contract data and all TTL entries in memory, and then to store instantiated contract code in memory. Now, with contract data and contract TTL, the thing that we store is the same size as the entry on disk. So for instance, like if you have a contract data on disk, that's the ledger entry is 64 bytes. Then we store 64 bytes in memory. So there's a 1-to-1 ratio for data and TTL. For contract code, this is not the case. Because of the module instantiation cache changes, or the instantiated module cache, we are not actually storing just the contract code bytes in memory, but we're storing an instantiated model. And this model can be up to 40 times the size of the on-disk WASM bytes in the worst case. And so what we're doing instead is that for contract code in particular, instead of using the size of the contract code entry for fees, which is what we've been doing up to this point, you're going to instead use the size of the memory given by the instantiated contract code module. And so in the worst case, this is a 40 times increase. But in the average case, this is only a 10 to 15 times increase over the size of the contract code as it's calculated today. And so that's change number one, is that essentially because we need to account for the in-memory size of state now instead of the on-disk size, we need to make this adjustment in the contract code size calculation. Now, the other adjustment we're making is with write fees. So for rent fees, essentially you are renting under Protocol 23, you are renting space in the in-memory cache of the network. That's essentially what rent is doing now. And so the rent fee will remain unchanged. How we still have like this target live state size, and then the rent fee will increase very rapidly if the amount of live state increases this thing. For write fees, it doesn't really make sense to have the write fee be a function of the current amount of live state. Now, because we're kind of transitioning to using memory-based bounds instead of disk-based bounds in the live state, a dynamic write fee doesn't make sense. And so what we're proposing is that we still need to have a write fee, but you are not. It doesn't need to be based on the current size of the bucket list. Rather, it just needs to be based on the computational cost of doing a write while you're applying the transaction. And so we're making a change that write fees are now a flat fee per byte, or per kilobyte rather. And so instead of having like this curve, the rent fees will still have that curve, but the write fees, there'll be a network config setting, which is fee per 1 kilobyte write. And then this will be applied based on the size of the entry you're writing. And this will be applied to both Soroban entries you write as well as classic entries you write. So that's the primary changes. Essentially, we are changing the way we calculate contract WASM size with respect to fees. Rent fee is still variable based on the amount of live state. Write fees are now flat. Any questions or concerns? I guess Morgan's question about the cheap storage. Essentially, we don't. It's not so much that the storage is cheap and then non-cheap. It's that before you hit the target, the storage is reasonably priced, and then past the target, the storage is like very, very ridiculously priced. So the idea is that we still, even before you hit the target, we still charge fees, and the intention of this fees is to dissuade people who aren't using who aren't legitimate apps using the space. But essentially, the reason that we have this target is that we don't want a DOS angle where an attacker could just write gigabytes and gigabytes of state that we all have to store in memory and then kill the nodes. And so I don't think the distinction is cheap versus non-cheap. It's reasonable versus like ridiculous pricing that we only resort to in kind of to protect ourselves from malicious attacks. See any numbers for the threshold? I think exact numbers are TBD. For reference, so currently we use bucket list total size, and so I think it's like 12.5 gigs or something like that. The target, something in that range. But because we're switching to only meter the live Soroban state, it'll probably be something on the scale of hundreds of megabytes. Just because today the total Soroban state size is like 40 or 50 megabytes. So that still gives us lots of growing room. But is a very small, validator requirement as far as memory. But again, we still need to think about these numbers a bit more. It's kind of, on the range of what we're looking at.
Yeah, to add to that, since WASM kind of takes more space now than it used to take in the database, yes, we need to reevaluate this in-memory state size, including the module cache, and I don't think we have done this yet. So, but the idea is I don't think it will be significantly bigger than tens or hundreds of megabytes, and threshold will be set, I think, quite high compared to that. Probably it can easily be a few times higher. So that, you know, we didn't get that much state in a year. I don't think, like if you set it to 2x, 3x of the current state, yeah, I don't think we'll run out of space anytime soon.
Yeah, and just to make it clear, for Morgan's question, like the purpose of these limits is not to limit good users. So if we see a DApp that has 100K daily active users, I mean that's not going to happen overnight. There's going to be a ramp up, but we would definitely probably introduce a slip for SLP to raise those limits. So the intention is not to reduce actual um, good usage of the network. Yeah, and I guess Nico pointed out a good point that I forgot to mention is that because we are switching from on-disk metering of contract code to in-memory metering, the size of the current instantiation model is protocol dependent. And so, for instance, if in the future we change to like a JIT instead of an interpreter, then the size of the instantiated model will increase. And so I didn't mention this, but for fees, we are for the rent fee in particular, we are using the in-memory size of the contract code. But for limits and for the write fee, we are using the on-disk size. And we have to do this because, for instance, like we have like a maximum contract size config setting, and if you can assume that a contract today has the maximum size, we wouldn't want to break that contract in a future protocol upgrade if the in-memory size just happened to change. And so, yeah, Nico, that's a good point I forgot to mention, is that only the rent fee is dependent on the contract in-memory size. And that means that and the target Soroban live state size is also calculated using the in-memory size of contract code. But as far as write fees and transaction write limits and contract code size limits, those are still determined by the WASM. And we have to do that because only the actual on-disk WASM size is consistent protocol to protocol.
Actually, so my comment was actually a little bit different, like because I had a chat with Graydon about this, and it sounds like the current pull request we have for CAP-0067 is actually caching per host, basically. So like if you have like two hosts, like core can be configured, right, with multiple hosts to support multiple protocol versions. And right now, we keep in memory the version of the WASM, basically like the pre-processed version per host. So it gets basically like if you have like two hosts in memory, it's going to have two versions of the WASM cache per contract. And that's kind of to make it easier to reason about, but at the same time, that means that the overhead in memory is actually dependent on how core is compiled.
Yeah, I think this is, I agree that it's something to look out for, but I think this is primarily an implementation detail at this point, because I think in the short term.
Yeah, no, it totally is. It's just like, that's why I said that there needs to be an SLP to kind of discuss that, because your memory limit basically that you pick has to take into account the fact that you have basically a overhead of 2 or 3x for the resident WASM. That maybe is not as trivial as if you look at calibration, like if you're asking one host how much memory are you using right now, that's actually not the truth. You need to basically lie through the network settings that you actually are going to count WASM in memory, let's say with a 3x a multiplier on top of what it's actually using per host. Does that make sense? It's basically the calibration settings.
Yeah. I think long term, so long term when we actually have like large amounts of states, say like in the gigabytes, then I think we can probably avoid this issue by doing something clever, like like if we are armed for an upgrade, then we can like like do the compiling for the new protocol version in the background lazily, and then serialize it such that we don't have like the double memory overhead. But yeah, I agree as far as like short term and medium term plan goes. I mean, I think like the state size is still small enough that like we can set limits like with these assumptions, it'd be fine. But yeah, I agree that we should have these this like 3x factor in mind. Cool. I guess if we don't have any other questions or comments about this, we can I'll hand it off to the next CAP.
Right. Yeah, thanks, Garant, for presenting this. And yes, the next thing we have on our agenda today is CAP-0067, and specifically the issues that concern handling of transaction memos and muxed accounts in the event. Not sure if CAP is even an appropriate link to share right now, because most of the relevant stuff is captured in the discussions to the CAP. I think the point of contention during the previous meeting was how exactly can we enable maxed accounts in Soroban, and after spiking a few options, considering the fact that it is likely for pretty much any custom token to be interested in being listed in centralized exchanges, and thus being compatible with custodial wallets that centralized exchange may use for multiplexing. It seems like this is something that most of the tokens will want, and I think this is one of the key requirements that kind of made the whole discussion pretty hard to converge on. But since we got came to an agreement that this is probably a reasonable feature to have, and contracts will need to deal with maxed addresses anyways, the current preference is to go with an option of adding seamless support of maxed addresses to the SDK into the environment, and what tokens extend, well, not extend, but update the transfer function interface to be able to accept maxed addresses. I don't know, Leigh, you do want to add something before we dive into details? You've asked to speak.
Yeah, I think maybe it's just worth calling out for people who were listening to the conversation last week. I think an assumption we were making, to be really clear, it was an assumption that this needed to be an extension. And I think, Tomer has sort of pointed out that it's safe to assume that pretty much every token would be interested in being listed in an exchange, if that was to happen. And so there's little reason to make this an extension where it's sort of targeting a very small number of tokens. Like really just sort of all tokens should be able to handle the case where they're given a mux address or a memo. And so much of the complexity, I think, in some of the spikes sort of disappears once we don't try to make this an extension.
Right. So to summarize, like what we are currently going to do with the protocol is that we will add a new object type to Soroban, specifically for handling maxed addresses, maxed accounts currently, but I'm actually not sure if you want to do contracts or not, but we could if we wanted to. And the interesting thing about it is that since it's in the protocol, well, the primary reason for why we are doing this work is for the tokens to be able to support this. Basically, any protocol will be able to use them if they wanted to. So if custodial solutions are necessary in some other protocols, basically the solutions where there is a single address that can have multiple virtual sub accounts, they will be able to implement this. And I think this is one of the benefits of this that hasn't been discussed before, even though like we don't have an immediate obvious use case, but you know, folks may come up with something. I definitely recall seeing some discussions here on Discord regarding virtual accounts for multiplexing support and so on. So yeah, we add this new object type, and also at the SDK level, we make it so the regular address type and this new multiplex address type are wrapped in the same SDK type, which means that, for example, if a contract just operates on the addresses and it doesn't know like that your token started accepting multiplexed addresses for the transfer, nothing will break. So for example, if contract A calls a token contract and passes a regular address, non-max address to it, things will keep working. Even the token contract updates to this new proposed feature, which is to allow transfers to have multiplexed destinations and sources. And this is what has been spiked, and this seems to kind of work. And in terms of complexity on the token side, it doesn't seem like there is too much. It's few additional lines of code to convert from multiplex addresses back to normal addresses that can do all the interesting things that addresses can do. That's kind of a high-level thing. I am not sure if we need to go too deep into details right now. I guess the conclusion from the discussions for diving is really that seems like we have a way of making this work in a non-disruptive fashion, meaning that the existing contracts will not be broken, and it is also possible for the clients to discover if a contract supports multiplexed addresses at all or not, which may be relevant in some context, right? So I think this part is more or less clear. A part that is still unclear, and I wanted to talk about a bit more, is how exactly are we going to represent the multiplex destinations in the events, and the option of just putting them into topic is problematic because it would break indexers if they don't do anything special. These multiplex addresses break in the sense that they will have too many virtual destinations that they really shouldn't be caring about. So in the link I posted, yeah, thanks Leigh for posting other discussions. Yeah, in the discussions that I've posted, Leigh has listed different approaches to actually how to handle the events with multiplex destinations. And I think we haven't reached a full agreement on this, but again, it seems like from my own preference, and I see Alex has commented on this, seems like what we could do is we could just converge. Yeah, Alex, I see you want to talk, but I guess the current preference is to converge all the possible memos that we currently have supporting the transaction, converge everything into the single multiplex address data structure, so that for the classic transactions, you will be able to generates a multiplex destination based on the transaction memo, even if this transaction memo is non-ID. And for Soroban use cases, it will only support ID memos to kind of reduce the potential amount of confusion. I know, Alex, if you wanna. Okay, Alex doesn't want to talk. I don't know if you wanna.
I'm happy to.
Yeah.
Yeah, no, I just, my comment was basically my preference, just as one point of view on like which one we should use. I guess I do have a question now thinking about it. Like, would this cause any breakage to how people parse muxed addresses if we were to expand muxed addresses to actually cover all types of memos?
Well, it depends on where exactly we put it. In the sketch I've posted above in the same discussion, I'm actually only extending SC address type, which means that classic max account data structure will stay as is. And the reason to keep it as is that it's kind of all over the place in the protocol. Like a lot of transactions have maxed accounts as sources or destinations, and yeah, there is really no good reason to kind of retroactively plumb all these memos into the classic max account type. And yeah, this memo will just remain in SC address, and it will be just yet another special SC address as a reminder of this CAP-0067 we introduced, like clonable balance SC address and liquidity pool SC address, and those can only appear in the context of this unified events, sources of or destinations of payments. And this is basically the third special address kind that only appears in unified events coming from Classic. I cannot say this will definitely not cause any breakage because, well, we are kind of, in order to achieve this, we need to not, well, kind of break, right, the token events by converting the data field from a single integer to a map. So there is definitely this breakage, and if someone does something to SC address, they may or may not be broken. So there's definitely some cost to it, but it's not really specific to this proposal of adding this maxed address with memo wherever new type, because we kind of already have this issue. So yeah, I hope the breakage scope is really minimal, especially if like we support this in string key libraries, and whoever is using string key library to just convert to and from SC address, they will just need to update the version, and hopefully everything just works. Yeah. George, you join the stage.
Yeah. I just wanted to add that, yeah, I 100% agree that we should minimize, that we should try not to make any changes to the actual muxed account XDR address or like the M string key format, because there's deep assumptions in a lot of places downstream, both in platform products and beyond in the ecosystem, about the M string key specifically having the integer as the ID. So yeah, if we can isolate that to SC address, that sounds great.
Right.
That is option 4, right? Or option 4, right? Yeah.
Or it's more like it's not option 3. I think option 3 is the only one that modifies the M string key.
Yeah, I think option 2 is the closest. Yeah, like using M wherever possible, but not trying to shoehorn text and hash into an M address. As long as we're talking about the string key representation, not some other representation.
Yes. Yeah, I think that's right. Yeah, I understand that concern. I personally, when I look at these 4 options, and I think there's more than these 4 options. So I think, if people have other ideas, like please post them to this thread. These are just the first 4 that came to mind. The attractive thing about the first option and the third option is that it's very consistent with what you see going into a transaction. I think for exchanges at least, or for legacy users. So if somebody puts in a memo that's a string, it comes out as being labeled. Here's the string in the exact, like it looks exactly the same. So if somebody's using developer tooling, they decode a transaction, they see this transaction had a particular memo, they decode the event, they can see the memo right there. Like they look exactly the same. And then the same thing if the memo is an integer, it looks exactly the same. And because we need to decode the M into a G for the topics, I don't think it's such a stretch for option 1 to like break it apart, and for even in the mux case, the integer to come out. At least there's some consistency there. The concern I have with the 2 case is that because it's sort of a little bit less consistent. You can create a transaction with a mux address and you get an M on the other side, which makes a lot of sense. But then you create a transaction with a G and a memo, and some memos result in an M, and some memos don't result in an M. So yeah, I don't know. This might just be, maybe this is an edge case we shouldn't worry too much about, but just that inconsistency seems surprising to me. I think it will be surprising to somebody.
Just to clarify real quick, isn't it normally the case that when people use the ID for differentiation on like omnibus or custodial accounts, that they would use the ID form? Like text and hash don't seem like they would apply necessarily there, so it might be like an edge case that they're attaching it as a piece of text that is supposed to like display something. So putting that into a memo would be
Text
it's not
does actually-
intended to differentiate.
Yeah, we should. I mean,
Sorry,
we
go
should
ahead.
use the BigQuery dataset just to validate, just to make sure we got these numbers exactly right. But when I've looked at this in the past, I have seen plenty of text usage actually. But a lot of the text usage is exchanges placing numbers into text form and then using the memo text.
I see. So kind of a misuse of the text form.
Yeah, I think Jake has just commented on that. I think just like our comments about what most exchanges are doing, we just need to validate that. Because I know like one exchange that actually does use muxed accounts, well, they support both muxed and non-muxed. For the non-muxed, they use text. And then for the muxed, they're obviously using the ID, which is interesting. I think one of the advantages of option 3, which modifies the M string key format so that it can contain more information, is that it sort of pushes everything towards that mux address format. I don't know if that would really change adoption of it, probably not. But it does create like a single unified view, and the data that comes out the other end. I'd be interested in Simon if he's here on like what the perspective is from like a data consumer's perspective, like a future data consumer perspective, assuming that the network will always have more users tomorrow than it does today. Yeah, like which of these approaches makes the most sense for future users and future consumers?
Hello. I would actually say I guess from like a big data or like OLAP perspective, I don't think any of these would cause a problem for scalability. Yeah, I'm not sure if that's helpful or not, but I think the amount of users that, unless it gets into, I guess, like the billions of something range, which I guess is theoretically possible, won't be an issue for like the next decade or so. I don't think this would be a problem from like an OLAP perspective.
What about from the perspective of you're a data engineer trying to represent this data, and so you're looking at a lot of the data, and a lot of the data has just a single value for this destination, and then in some cases, oh, this value is actually a combination of multiple fields or something like that. Does that make it more or less difficult when integrating into other systems, or would that be like a concern or something that could be like a foot gun, or so, like something that'd be easy to make a mistake with?
I think for our use case, I don't really have a concern with it. I think the concern would be more for whoever is ingesting from like RPC or creating like some Horizon-like endpoint. So I don't know if I'm the best to speak on that.
Yeah, from Horizon, so from Horizon's perspective, because we already support M addresses in their current form, it would be like the format itself would break, right? Because you would need a way to distinguish what kind of memo it is now. And so anybody who's relying on the current string key format would no longer be able to use the same string key format, right? Any existing, queries or lookups or parsing routines, anyone who's trying to find stuff in Hubble, right? They would have to reformulate their muxed address, as far as I understand it. I mean, it depends on how it gets formatted in the XDR, I guess, or how the string key definition defines it. But yeah, it seems like this would cause a lot of pain for downstream if we extended it to be more than just strictly integer IDs.
I think it can. When I had a look at, I did a quick spike having a look at what would need to change about the M string key, and it's 100% extendable without breaking existing string keys. So without confusion, so like existing string keys would continue to decode to the exact same value, and for any existing decoder that follows the spec, any new string key wouldn't overlap with any existing string key, so that every new string key that didn't follow a different format would definitely fail. Like say, like when I say new, I mean like the text, the return, and the hash types of memo types. So I think we definitely could do that, but without breaking existing systems. But whether that's the right way still to do that is another question. Based on there will be systems that probably won't upgrade to the new format, and they might assume that there's nothing to change, and then they become broken. Yeah, I don't know. I'm interested to hear, like, Nico, you were just talking about exchanges will crack open the M address for case 3, so that's strictly worse as a use case. Could you unpack that a little bit?
Yeah, I mean, it's basically like, in the ingestion system, what they are looking at is deposits to their hot wallet, and then the memo. That's how they, ingest the data. Like, I don't see like why they would want to basically track like M addresses as the kind of the deposit key for separate from the hot wallet, basically.
Yeah, that's a good point. Also, for exchanges that define those identifiers like per customer too. Like you are really interested in that identifier, whether it be an ID or a string. I think what I hear you saying is that exchanges actually just don't really care about the M address after that import, other than using it as an input so that users can just enter that one value. When they're ingesting the system, it doesn't really matter.
I guess you can still argue that as someone who's we're basically deciding what is going to be published as an event, but you can always go back and forth between the M or the address plus memo, right? And you could abstract that away in the SDK or even like as an indexer. who's actually ingesting this data and converting and serving it however you want, right? So does it really matter? I think the point about breakage though is very important, right? Because I feel like you first said it wouldn't cause any breakage, but for anyone who is parsing current M addresses and they don't upgrade their implementation to the new thing, if they see an address that is using the extended version, they would probably break, right?
I think there's
Yeah,
some,
in that case, they're not going to be able to decode it because it'll be a different format.
yeah, I think there's some confusion because I think we might be reading these proposals differently. I do not think any proposal assumes immediate string keys anywhere in the events.
Yeah, that's actually
I-
exactly what I was about to ask. Like, what when we
Yeah.
say from M and to M, right? In the transfer topic, from G and to G is an address.
Yes.
Not a string key,
Basically, in my mind, from G to G means that from SC address account ED25 whatever to SC address account, and from M to M means SC address maxed account, which I have introduced in my spike, right? And SC address maxed account variant has the max account XDR payload, which is the existing max account, which it doesn't even have to be frank. Like it could be just, ED plus ID, so there is no additional level of enumeration. And the same goes for this new memo account. From the XDR standpoint, it can be just a variant of a C address that contains G, ED25 key and memo, which is just the transaction memo type, for example. So the string key discussion is rather like how do we like if you want to convert it to string key or not, but the event structure does not change, I think.
I think there is an impact here. So yes, string keys are not part of the protocol and they're not part of the XDR, but they are part of the developer experience. And how we structure this will impact it to a degree. So I agree that we can bundle these two pieces of information, the address, the actual address, and the memo separately or together in different structures, the same structures. But we do need to make a decision in the event if it's a toplet, like if this event, the data section is going to become a map. Is one of these fields going to be something that we expect to be a single unit, or are we going to expect them to be separate units? And so that affects how it's going to render in things like the developer tooling in the RPC JSON API. Because that's where we actually do map things to string keys, and they either map or they don't map well.
Oh, yeah,
So if we make them like separate fields in the data, nothing that we built today for developer tooling is going to be able to map those things to a string key if we want them to be a string key. If we put them in a single field, then we have that option. But that may or may not be a good idea.
Yeah,
and then we're also talking about
Yeah.
redundant data too. So does it, if the G is in the topic, does it really make sense to spend another 32 bytes and actually keep that G in the data as well? That's unclear to me.
Right. Yeah. Yeah. I just want to point out that like basically for the exchanges, I don't think any option is specifically like bad or inefficient because like they will still have ID somewhere in the event. So they will never need to like parse this out of string key. As for the overhead, yeah, I think it's a valid concern.
Yeah, I think like number one, I think Nico sort of pointed out that was an option that is like low risk of doing the wrong thing with. Like option one is so simple, that everything's pulled apart, you've got everything there in the event. The really only downside of option one, where everything's broken apart, is the developer experience isn't quite the same. So when you're looking at a human readable version of an event, you're going to see this memo and a G address. You're not going to see that M that was in the original. But this already happens everywhere. When you go to a Stellar.expert or other explorers and you drop in an M address, it immediately drops you into a page about the G address. So I don't actually think we need to have complete consistency with M address goes in, M address comes out. Yeah.
Yeah,
I guess I would
maybe.
just generally say I'm generally for option one. I think it's simple, the messages are smaller.
Yeah, I think this may be fine. And also like for the consistency part, like at least like if you can have M addresses in the contract invocations, things are immediately much less confusing because if you ever wanted to check your transaction, like there is a very good chance that Block Explorer will correctly say that you actually have performed the transfer to an M address and not some pair, which was my concern for the input. But for the events, I agree it may be not as important, and events are generally much less human readable. So maybe, yeah, it's not worth to optimize for exactly the same rendering as we would have expected from the signature of the function. So yeah, I think option one is probably fine.
Okay, so it sounds like we're leaning towards option one. No one's opposed to that. If so, we can move on to the next topic.
Yeah, I'm good.
All right. The next thing I think we should discuss is what to do about the TX memo, if we should admit that as a separate event. Because for example, if you're replaying, if an exchange is replaying using classic events, and someone sent a payment to Coinbase with the TX memo and the muxed account, we don't have space in the current events as they're defined to include both the TX memo and the mux information. So an option that Dima mentioned is we could just emit a system event similar to how CAP-0067 emits a fee event. That event will just contain the TX memo if one existed. Anyone have any thoughts on that?
I mean, like you're saying, sorry, like, so you're saying like you would not emit a muxed or whatever, like, this destination memo event if you have a transaction memo?
No. So what I'm saying is, like on a payment, if you use a mux account, you will have a destination memo in the transfer event, right?
Mm-hmm.
But if that transaction also had a TX memo set, what do you do?
Yeah, but first of all, like I'd like to understand what happens if you only have a transaction memo and not a mux destination.
Yeah, so the cap currently that says that there's like an order of precedence. So
Yeah.
you would pull the TX memo and put it into the event. But if you emitted the TX memo separately, it would probably make sense to ignore that order of precedence and have the consumer pull the information that they want. Right?
No, that's
You
I
don't think
think
so?
mistake. Yeah, because we saw with Horizon, right, like this model where you let clients kind of decide. I think this is the opportunity to actually fully specify this precedence order so that you don't have ambiguity, right? Because I'm pretty sure. I mean, I don't know. I don't want to put exchanges in in trouble, but I imagine that this precedence order is not actually respected because it's actually fairly complicated.
No. Well, let's step back for a second. Is the ability for an exchange to replay from Genesis using events a requirement? Because if it is, then you can't make assumptions about if they care. Like certain exchanges may care about the TX memo and some may care about the mux information, right?
I think this is a new event stream, so we get to do what makes sense. If I think yes, you don't want to lose the information that there was a TX memo.
Yeah.
At the same time, I do think that the transfer events should contain the what we think is the I mean as per the specification of transfer events what we believe is the right destination memo in this case.
Yeah,
So
and I think on that point, it doesn't. I'm not actually sure if can't we change this? This is a new event stream, so the replay can use the new semantics, while the previous versions of meta and the transactions still describe the old semantics.
Yeah, the events can do whatever we they can be specified however we want them to be. Maybe I wasn't clear. Like what I was initially saying is that the TX memo would be in this new event, and then the transfer event would only have mux account information. And I think Nico, you're saying that in some cases we should push the TX memo into the transfer event as well.
I think if we are going forward, like it's more like what do we want those events to look like for classic events? I think we want them to properly represent the destination, and therefore you need to see the transfer event with the proper destination plus memo, like option 1, let's say, right?
Yeah.
Even if the memo is actually at has been specified at the transaction only at the transaction layer.
Okay, so if the count wasn't muxed, then forward the memo into the transfer event, and still emit the memo
event. It will be
event.
basically indistinguishable if you have like only the transaction level memo, only the destination muxed account on either transaction or operation, right? Those 3 cases should all end up with the right transfer event with the added memo information. As far as like do we need an event for the memo? I don't know what the use cases for that are. So yeah, like people, you can already get that by pulling the transaction itself and cracking it open, basically, if you really want that.
But I agree that you can do that, but didn't we want the consumers to not have to do that? Or I guess it depends on if that's a requirement or not. Like, do we care about?
In the context of I think the context of the CAP was transfers. In the context of transfers, this seems to be out of scope.
Okay.
Sorry, I'm not totally tracking with what we've just said.
So Nico is saying that the emitting an event purely for the TX memo, like a separate event, is out of scope in the context of transfers. I'm not sure about this. I'm specifically thinking about the replay case for exchanges. Because what happens if you have a transaction of the TX memo and mux destination account? Because without the TX memo event, you can only show one, right?
But in that case, the thing is that if people have like complex logic, they will have to actually derive it from the transaction. They have to know exactly, okay, which combination of things, right, were they into? I think that's why I'm saying like the transaction memo is not sufficient. If you're starting to pull that thread, like you have to do transaction memo, source account on the transaction, destination. Actually, no, this one, I guess the override can only happen on the 2, so there's only one place. But if it's the source, that's where you have the transaction source or the operation source, right? That are ambiguous.
Yeah, the source does make this look more complicated.
This is I'm actually not sure if the source makes it that much more complicated, does it? Isn't the complexity that an exchange might be reading the TX memo today and actually ignoring the the mux address, and just using the G part of the mux address? Isn't that the complex part?
Yeah. Well, so that's the scenario that this event might help you solve, maybe. right? Because I'm sure that I'm guessing that happens today. Like if I send a payment to Coinbase with the mux account set and the TX memo, like they probably just, I'm guessing they treat it as if the account wasn't muxed, right?
No.
That's what we don't know because it's under specified.
Okay, I guess for this we'll
Like to me that this discussion is more like I see the historical stuff as more like as a best effort, because really like exchanges in particular, are they really, I mean, do you really want people to be re-ingesting from Genesis or something like they already
yeah, it's a good
ingested,
point.
already reconciled all this data in their backend.
Yeah,
Right.
that's a good point. Okay.
There's also the additional ambiguity of if someone's sending to a M address and has a memo at your transaction level, you shouldn't necessarily assume that that transaction memo is a specification of a user on the destination side, right? It could just be some free text just for the purposes of describing the transaction.
Yeah, the point of this event was just to show all the information and have the consumers deal with it. But it sounds like we don't need to deal with this right now. Also, we're out of time. The last thing we were going to discuss, we can maybe do this offline, is that we no longer need CAP-64. But
Yeah.
I don't know, Dima, if you want to say anything about that.
Yeah, I guess the consensus of the discussions has been that CAP-64 is not needed, and yeah, I guess this is just an official announcement that we are close on it because memos will be implemented differently. Yeah, that's it.
All right, then we're out of time for today. Thank you for joining, and thanks everyone for participating.